triangles. You will see on the side of your page that we're going to do SOHCAHTOA. I know we did that. I don't remember what we used it for yet this year, but we did. So we'll do SOHCAHTOA. We'll do a little bit of Pythagorean theorem as well. So two concepts that I think that you're very familiar with, but we just need to go over those. Okay. So the first thing is every triangle that we solve today is going to be a right triangle. Okay? Every single triangle is going to be a right triangle. Okay. Now the right triangle. The right triangle is going to be composed of a right angle and two acute angles. Okay, what are acute angles?
Smaller than 90.
Smaller than 90, right? So two of those. Okay, our first angle is angle theta. Okay, angle theta is your base angle. So if you look over here on the left-hand side, you will see theta is labeled there at the base. It's the one that is our standard position angle. When we talk about angles, we start with standard position on the x-axis. That's the one that's going to be theta. Okay, the next one, in this case, is phi. Sometimes it'll be alpha. Okay, so we'll kind of change between the two. But you'll see that one up here in the corner. Okay, that's the step one you're shooting. That obviously cover 90 degree. Okay, the adjacent side. Okay, adjacent means right next to. Okay, so adjacent is right next to. And then we have our opposite side. Okay, that's the side opposite. We'll say theta in this example. And all of those are labeled on your triangle on the left. And then your hypotenuse is opposite that 90 degree angle. Hypotenuse is opposite your 90 degree angle. That's all. Alright, so let's go ahead and pick out our trig functions for our triangle here on the left. If I start with theta, theta is this angle right here. We're going to do everything in reference to theta. So sine is opposite over hypotenuse. If I'm looking at theta, which side is opposite theta? 4. Okay, so it'd be 4 over hypotenuse is what? 5. So 4 over 5 for our sine function. Okay, cosine is adjacent over hypotenuse. Which side is adjacent to theta? 3. Again, our hypotenuse is 5. Tangent will be opposite over adjacent. So opposite we already said is 4. Adjacent we said was 3. Keep in mind, all of this is in reference to angle theta. And cotangent is opposite of what? Tangent. So tangent was 4 over 3. Flip that fraction. Your tangent is 0 over 4. Okay, secant is opposite of cosine. Okay, so cosine was 3 over 5. Secant is 5 over 3. And then obviously cosecant is the opposite of sine. Flip that fraction. I want you to try alpha on your own. Go ahead and get the 6 trig functions for alpha all on your own.
Was it like you came into 23? I realized that.
Yeah, I don't think we were actually so I think we might have to layer something.
All right, there's your answers for alpha. Okay, any issues on those? Pretty easy. Okay, last question on this one. What's the relationship between alpha and theta? What's the relationship? Think about their characteristics. What's the relationship? Yeah, we think. Yes, so break that down. So if we know where you have a 90-degree angle, what should those two add to? 90, right? A triangle is 180. You already have a 90-degree angle, so alpha and theta should add to 90. Okay, they should add to 90 degrees. All right, if we are not given any angles, we have to use the Pythagorean theorem to help us solve for triangles. Okay, so this one says solve for the missing side. Does anybody remember Pythagorean theorem? Yeah.
A squared plus b squared plus c squared.
Okay, if you didn't remember it, you probably subconsciously remembered it. Okay, we said it a lot in math. All right, side A will be 6 because that's a leg. Side B is obviously already labeled for you. And then side C is our hypotenuse. A and B are interchangeable. They're both legs. It doesn't matter which one you write first. But C always has to be that hypotenuse. We set this up plus 6 squared plus B squared equals 10 squared. Because 10 is our hypotenuse. We're going to solve for B. First thing we need to do is get rid of squares. What's 6 squared? 36. Thank you. Whoever said that. What's 10 squared? 100. Okay, subtract 36. And then take your square root of both sides, and you should get B is 8, and our unit is inches. And we can find that in our triangle. So be cautious of your label. All right, we're going to solve some triangles. When I say solve the triangle, I'm not asking you to solve one part of the triangle. I'm asking you to solve the whole thing. Okay? Yes, these have multiple steps. We're going to do it together, and it's going to be awesome. Okay. The first thing I want you to look for is what are you given? Okay? Look at two things. Are you given two angles, or are you given two sides? You will be given at least those. Right? So do we have two sides here? No, we have two angles. Beautiful. Okay, these are my favorite ones. When we have two angles, it's really nice to get that third angle. How am I going to get my third angle? Subtract from 180. So 180 minus my 90 degree minus my 40 degrees. That's going to give me my third angle, which happens to be what? 50 degrees. Okay, if you're not sure, go ahead and do it in your calculator. No big deal. Okay, and that's going to be angle B. Angle B is 50 degrees. let's find side A next. It doesn't really matter where you go, what you do, but let's go ahead and we'll do A and find A together. Now, in order to do this, we can't do Pythagorean theorem because we don't have two sides already. We have to use trig. Okay, trig being subtotal. So, if you look at 40 degrees, okay, how does side A relate to 40 degrees? Is it opposite, adjacent, or hypotenuse? Adjacent. No.
Wait, that's the hypotenuse.
How does it relate to 40 degrees? Opposite. Okay? So we have opposite. And then what is B? Because we have to use side B. What's this one? Adjacent. Okay? Which trig function is opposite over adjacent? Tangent. All right. So we're doing tangent of 40 degrees equals opposite letter A, we don't know what it is, over adjacent, which is 6. Okay, now to solve, multiply both sides by 6, and that will get A all alone. Grab your calculator. We got some work to do. Now your calculator is probably not ready to be used for these problems. I'm going to help you with the settings part. There's some settings that we may need to change. Okay, if you have a TA Inspire, hold on for just a sec. If you have the 83, 84 buttons, take a look up here. You're going to press mode. Mode. Okay, 4th line down, it will say radian, and it will say degree. Make sure that degree is highlighted and press enter. Okay, that means that the angles that you are entering in your calculator are degree. They're not radians, but pi. Okay, so we're going to be working in degree mode. Press second, quit, you're ready to roll. My TI Inspire friends, you're going to press dock. You're going to go down to number 7, and I believe that number 7 reads, who has an Inspire? Nobody? All right, never mind. Inspires. Okay. You have an Inspire?
I do, I just looked at them.
All right, we'll get it. Okay. Anybody else Inspire? Okay, never mind. Never mind the Inspire. All right. So, this is what we have. Why didn't I do that? Okay, we're going to put it in. We're ready to go. 6 tangent 40. Okay, you should get 5.03. If you did not, raise your hand. I'll help you out. You probably were in the wrong mode or something. Any issue? All right. So that tells us that side A is 5.03. And in this case, we're going to have units because there's no label. Okay, now, I'm going to tell you, if you use 5.03 for the rest of your work and the rest of your problem, you may be a little off on your answers because we had to round that. Okay, so the most that you can, try to use what you were originally given. Okay, so we're going to aim to use side 6 again when we solve for our hypotenuse. You with me on that? Does that make sense? Okay. So, if I look, we'll just stick with angle 40. You could use angle 50 if you wanted. How does 40 relate to angle 6? Adjacent, right? And then we have hypotenuse. So adjacent and hypotenuse is which trig function? Are you alive? Which trig function is adjacent over hypotenuse? Cosine. Okay, cosine of 40 degrees equals adjacent 6 over hypotenuse, we'll just label it C. Okay, now, if you want to solve this, I'm going to show you a quick trick. Okay, typically what we would do is just watch. I want you to write this down. Okay, we would multiply by C, right? We would divide by cosine 40. So then we end up with C equals 6 over cosine. Okay, that's what we would do. Now, I want you, I know it's going to be hard to see, so I'm going to go back. I'm going to undo that. So this is what I ended up with. What happened? During that whole process, what happened? Yeah, okay. I flipped them, right? I literally took C and put it here and cosine put it there. So that is the work that would happen if you went there. I don't need you to do it. You're going to know from now on, if I have my variable in the denominator, I can flip it with the other side, okay? It's a quick trick, so I don't want you to have to worry about doing that work. Just flip them. You with me on that? Does that make sense? Okay. Because that's where a lot of people get, they get a little mixed up on those, so I don't want you to have to worry about that. We'll just use our quick trick on that. Okay, we're going to put it in our calculator. Should get about 7.8. Let me know if you don't get 7.8. Something probably happened. Or we're in the wrong boat. Okay, are we okay on that? Yes? Okay, so we have now solved for each side. Hypotenuse was 7.8. Okay, these are long. They just take a little bit of time. They're not hard. I think they're tedious because you'll get used to what you're doing. All right, next one. What do we have? Remember I told you to look for two things. Two angles or two sides? Two sides. What are we going to have to do if we only have sides? Put that right here. Okay. Which side are we missing? A, B, or C? B. Okay, actually you're wrong, but that's fine. Okay, it doesn't matter. It doesn't matter if it's A or B. Here's the reason. What we do is we look across from. I have B. I just have B because it's the side across from it. If you build in 14 for A, it's not a big deal. Okay, but technically what we're missing is we're missing side A. Okay, so I'm going to leave it as A. B is 14. C is 21. All right. I think 21 squared is 441. Remind me, is that right? We did the calculator. Yeah, okay. All right, 196. 245. It's 15 point something. I guess it's 15.6. 15.7.
That's triangle is not.
No, it's not. Okay, now, do you think I want you using 15.7 for the rest of your work? Not if you can help it. Okay, because we rounded it. That's going to round to everything else. Okay. All right, let's go ahead and solve for an angle. Which one do you want to find, A or B? Doesn't matter.
A.
A it is. Okay, now, I don't want to use this side. Let's try to avoid that side. So let's use 14 and 21. How does side 14 relate to angle A? Adjacent? Yes. And what is side 21? Adjacent and hypotenuse, which is which trig function? Cosine. So we do cosine of angle A. We always write an angle as a capital letter. Okay, and then we said adjacent 14 over hypotenuse, which is 21. All right, throw back here. Does anybody remember what calculator work we have to do to find the angle? Anybody remember? Okay, here's what you do. A equals, okay, to find an angle, we have to do inverse trig. Okay, so cosine to the negative first of our fraction, which is 14 over 21. Okay, so here's how we do it. Press second cosine. That's where you should see that cosine to the negative first. Right, and then 14 divided by 21. You should get 48 point, round it to 2. 48.2. All right, good. Only when you're finding an angle. Yeah. So, and that's a really, so you might want to make a little note, maybe in the left-hand column over there. We only use inverse trig for finding an angle. The only time we use it when we're finding an angle. Okay, so angle A was 48.2 degrees. You have options for finding angle B. What's one option?
180 minus 62.
Okay, use the other angle. 180 or other angles. 180 minus 90 minus 48.2. Could you use trig? Yeah. You have to decide what you like. I don't care what you do, honestly. Okay, I really don't. So I would, since it's easier, all right, let's think smarter, not harder here. 180 minus 90 minus 48.2. 42.8. Yeah? No. 41.8. Okay, so that should be angle B. Oh, it's funny. Okay, now if you add 41.8, 42, 48.2, and 90, you should end up with 180. Okay, obviously that would be. Okay, questions, issues, concerns? All right, where would you start on this next one? We're solving the whole thing. Okay, we have two sides. So you're going to start with Pythagorean theorem. I want you to do it on your own. Okay, starting with Pythagorean theorems.
Is there like a rule that can be as adaptations they go? Someone's looking. It doesn't.
Okay, don't stop there. Once you get the Pythagorean theorem, see if you can find an angle. And if you Street to help you. Do as much on this one as you can on your own. Don't feel bad looking to the front and finding silver toe if you need it. It's totally fine. Okay, now you may not be doing the same thing that I did, and that's okay. Okay, that's the beauty of these problems. You don't have to do it the exact same way that I did it. Okay, but we will end up with the same answers at least. Whatever you choose to do. So if you can choose this X, and you choose these two, that's opposite explanation. But if you choose 6 and 10, you guys can choose. So it all just depends on what you can choose to do. Because that's the one that you're solving for. You were solving for this one, and for the other that. Okay, any issues or concerns? Would you like me to do it your way? Okay, and see, like maybe you didn't get the same answers? Any issues? Don't be shy. Oh. Okay, we good? Alright, next one. Do it right all on your own? Yeah? Alright, I'm gonna let you go for it. Remember, decide, do you have 2 angles or do you have 2 sides? That determines what you do. That will help you. you do it a different way than I do it, that doesn't mean that you're wrong. You're just using a different method. Check those answers once you get that finished. Okay, if something happened and you're not really sure what, let's take a look.